The National Electrical Code, or NEC, does cover grandfathered wiring. Grandfathered wiring refers to electrical installations that were compliant with the code at the time of their installation but may not meet the current code requirements. It is important to understand the differences between 220-volt 2-wire and 3-wire wiring systems. 220-volt 2-wire wiring is commonly found in older buildings. It consists of two ungrounded, or hot, wires, typically black and red, and a ground wire, which is bare or green. This configuration provides 220 volts between the two hot wires. 220-volt 3-wire wiring is used in modern buildings and appliances. It consists of two ungrounded wires, typically black and red, a neutral wire, which is white, and a ground wire, which is bare or green. This provides 220 volts between the two hot wires and 110 volts between each hot wire and the neutral wire. If you have an old building with 220-volt 2-wire wiring and want to install new equipment that requires 220-volt 3-wire wiring, NEC Section 408.3b would apply. NEC Section 408.3b states that existing installations utilizing 2-wire branch circuits with two ungrounded conductors and a grounding conductor shall be permitted to be continued in use. Where such circuits are extended or altered, they shall be provided with a 3-wire grounding type receptacle and shall be grounded by the connection of the grounding conductor to a grounding electrode system. This rule allows for grandfathered wiring to continue in use. However, when the circuit is extended or altered, it must be updated to include a 3-wire receptacle and a grounding system. To comply with the NEC, firstly, hire a licensed electrician to inspect the existing wiring and determine if it is safe to use. Secondly, if the existing wiring is safe, have the electrician extend or alter the circuit as necessary, including the installation of a 3-wire receptacle and grounding system. Thirdly, have the electrician obtain the necessary permit and have the work inspected by the local building department. It's important to elaborate on the implications of NEC Section 408.3b and related sections to ensure comprehensive understanding and compliance. When dealing with grandfathered wiring, it is crucial to assess the overall condition of the existing electrical system. While Section 408.3b permits the continued use of 2-wire branch circuits under certain conditions, it doesn't negate the responsibility to ensure the entire system is safe and functioning correctly. This assessment should include checking for damaged or deteriorated wiring, loose connections, and outdated components. If any issues are identified, they should be addressed before any modifications or extensions are made. Furthermore, it's essential to understand the specific requirements for grounding and bonding in older electrical systems. Grounding provides a path for fault current to return to the source, tripping a circuit breaker or fuse and preventing electrical shock. Bonding ensures that all metallic parts of the electrical system are at the same electrical potential, reducing the risk of shock. In older systems, the grounding and bonding methods may not meet current standards. Therefore, it may be necessary to upgrade the grounding and bonding system to comply with the latest NEC requirements. This could involve installing new grounding electrodes, upgrading grounding conductors, and bonding metallic components. When extending or altering a 2-wire branch circuit, it's important to consider the load requirements of the new equipment being installed. The existing circuit may not be adequately sized to handle the additional load. In this case, it may be necessary to install a new branch circuit that is properly sized for the load. This new circuit should comply with all current NEC requirements, including the use of 3-wire wiring and a dedicated grounding conductor. It's also important to ensure that the new equipment being installed is compatible with the existing electrical system. This includes verifying the voltage and amperage requirements of the equipment and ensuring that the existing wiring and circuit breakers are properly rated. If the equipment is not compatible with the existing system, it may be necessary to install a new circuit or upgrade the existing one. When installing a 3-wire receptacle on a 2-wire branch circuit, it's important to properly connect the grounding conductor. The grounding conductor should be connected to a grounding electrode system such as a ground rod or a metal water pipe. This will provide a path for fault current to return to the source and trip a circuit breaker or fuse. It's also important to ensure that the grounding conductor is properly sized for the circuit. The size of the grounding conductor is determined by the size of the circuit conductors. The NEC provides tables that specify the minimum size of the grounding conductor for different circuit sizes. In addition to the requirements of Section 408.3b, there may be other NEC sections that apply to the installation. For example, Section 110.3b requires that all electrical equipment be installed and used in accordance with its listing and labeling. This means that the equipment must be installed according to the manufacturer's instructions and must be used for its intended purpose. Section 300 covers general wiring methods and requirements. It addresses issues such as the type of wiring allowed, the methods for supporting and protecting wiring, and the requirements for installing wiring in different environments. Section 310 covers conductors for general wiring. It addresses issues such as the ampacity of conductors, the types of insulation allowed, and the requirements for derriting conductors in certain conditions. Section 406 covers receptacles, cord connectors, and attachment plugs. It addresses issues such as the type of receptacles required in different locations, the grounding requirements for receptacles, and the requirements for tamper-resistant receptacles. Section 250 contains the requirements for grounding and bonding. It addresses issues such as the types of grounding electrodes allowed, the methods for connecting grounding conductors, and the requirements for bonding metallic parts of the electrical system. Furthermore, it's essential to consider the local building codes and regulations in addition to the NEC. Local codes may have additional requirements or restrictions that must be followed. It's important to check with the local building department to determine the specific requirements in your area. When working with electrical systems, it's always important to prioritize safety. Electricity can be dangerous, and it's important to take precautions to avoid electrical shock. Always disconnect the power before working on any electrical equipment. Use insulated tools and wear appropriate personal protective equipment, such as gloves and safety glasses. If you're not comfortable working with electricity, hire a qualified electrician to do the work. Ensuring compliance with the NEC and local code requires a systematic approach. Firstly, conduct a thorough inspection of the existing electrical system. Document all existing conditions, including the type of wiring, the size of conductors, the grounding and bonding methods, and the condition of all components. Secondly, determine the requirements of the new equipment being installed. This includes the voltage, amperage, and grounding requirements. Thirdly, identify any code violations or safety hazards in the existing system. These should be corrected before any new work is performed. Fourthly, develop a plan for the installation that complies with all applicable codes and regulations. This plan should include detailed drawings and specifications. Fifthly, obtain all necessary permits from the local building department. Sixthly, perform the installation according to the approved plan. Seventhly, have the work inspected by the local building department to ensure compliance with the codes. Maintaining proper documentation is crucial for future reference and for demonstrating compliance with the NEC. Keep records of all inspections, tests, repairs, and modifications performed on the electrical system. These records should include dates, descriptions of the work performed, and the names of the individuals who performed the work. Furthermore, it is important to understand the concept of arc fault circuit interrupters, RFCIs, and ground fault circuit interrupters, or GFCIs, and where they are required by the NEC. RFCIs protect against fires caused by arcing faults, while GFCIs protect against electrical shock caused by ground faults. The NEC requires RFCIs in many branch circuits that supply dwelling units, including those that serve bedrooms, living rooms, and dining rooms. The NEC requires GFCIs in receptacles located in bathrooms, kitchens, and other wet locations. Staying up to date with the latest version of the NEC is crucial for ensuring compliance and safety. The NEC is updated every 3 years, and it's important to be aware of the changes and how they affect your electrical installations. You can purchase a copy of the NEC from the National Fire Protection Association or view it online. Furthermore, a Attending continuing education courses and seminars can help you stay up to date with the latest codes and regulations. These courses can provide valuable information on new technologies, best practices, and code changes. Choosing a qualified electrician is essential for ensuring that the electrical work is performed safely and correctly. A qualified electrician should be licensed, insured, and experienced in the type of work you need done. They should also be familiar with the NEC and local codes. You can verify an electrician's license by contacting the local licensing board. You can also ask for references from previous customers. Communicating effectively with your electrician is crucial for ensuring that the work is done to your satisfaction. Be clear about your expectations and ask questions if you don't understand something. Review the electrician's proposal carefully before signing it, and make sure that it includes a detailed scope of work, a price breakdown, and a timeline for completion. Finally, remember that electrical safety is everyone's responsibility. By following these guidelines and working with a qualified electrician, you can ensure that your electrical system is safe and compliant with the NEC and local codes.